I'm Erica Zavaleta, and this is Ecosystems of California. Estuaries are the places where rivers meet the sea in an intermingling tidal system of fresh and salty water. California has not had very many estuaries in its history because of its steep and rocky coastline, and it's also lost some of its estuarine systems to land use change, drainage, and diking. Nevertheless, California is still home to some spectacular estuarine ecosystems. Some of them are notable for their size. The San Francisco Bay Delta estuary once drained 40% of the state's area and itself extended over an area the size of Rhode Island. Others are notable for the ecosystem services that they provide. And one example of that is where we're visiting today at Elkhorn Slough National Estuarine Research Reserve. This reserve provides a variety of ecosystem services, ranging from wildlife habitat for migratory birds, marine mammals, and rearing sharks and fishes, to services like filtering nitrogen and phosphorus and other pollutants from agricultural runoff that enters the slough from the agricultural landscape upstream before it enters the open ocean. Today we're visiting Elkhorn Slough Reserve, and we're going to start out with Kirstine Moisson, who works with the reserve on a variety of restoration and research projects.
How our ability to improve global warming has changed. Estuaries have a variety of habitat types that are almost as different as grasslands and forests and alpine systems. They change really dramatically along an elevation of the tides. So highest up we have salt marshes, which are some of the most productive ecosystems on Earth. Below those are the mudflats, full of worms and crustaceans and small clams that feed migratory shorebirds and fish and marine mammals. And then below that are the channels and creeks, which remain full of standing water all the time. Estuaries have been the places that people come to live because the land is so productive in the floodplain around rivers where they run into the ocean, and agriculture is really important in this region. The lands are very productive. For instance, farms around the Elkhorn Slough region supply something like 20% of the strawberries for the whole nation. But agriculture has had some strong effects on our estuarine ecosystems. For instance, the Salinas River used to run into Elkhorn Slough, providing the estuary fresh water, but it was diverted to prevent flooding of floodplain fields. Also, groundwater has been used really extensively, and so we don't have these seeps that give us rushes and sedges on the edges of our salt marshes anymore. And probably the biggest impact has been through diking and draining. Something like 50% of the estuary has been diked and drained, and parts of the estuarine wetland used directly for agriculture. A final major impact is from agricultural runoff. Pollution from the farm fields enters the system, and there are pesticides and herbicides and especially nutrients, fertilizers, that fertilize the estuary, and so they grow algae, too much of it, and that's bad for our estuarine system. It can decrease the oxygen at nighttime to levels that fish and other animals can't tolerate. Thousands of visitors come to Elkhorn Slough from all over the world and just from the surrounding area to see the shorebirds up close, to kayak among sea otters, to experience estuarine ecosystems. And we want to conserve and restore these ecosystems as a legacy for future generations of visitors. We're really excited about the Tidal Marsh Restoration Project. It's the first major marsh restoration project in this estuary, which has lost something like 50% of its salt marsh over the past 150 years. So salt marshes occupy a really narrow elevational range in the tidal frame. If they're too high, they dry out. If they're too low, they drown. During the history of Elkhorn Slough, when marshes were diked and drained and used for cattle grazing or for farming crops, the soils in those areas dried out and shrunk like your kitchen sponge. And so later on, when nature reserves came in and returned the tidal exchange, the salt marsh didn't return. There were high mudflats and lagoons in those areas because the soils were too low. So what we're going to do is use beneficial reuse of sediment from another project that generated sediment and build the elevation back up to where it needs to be to sustain healthy salt marsh. And not only that, we're going to go a little bit higher to make sure the system is resilient in the face of sea level rise. So hopefully, a few decades from now, the two sides of this former dike will look the same.
What are some of the ecosystem services that a healthy marsh like this provides?
Yeah, there's a whole variety, but as two examples, one is to provide habitat for wildlife, such as the sea otters that use these creeks for foraging and haul out on the salt marshes. At the other end of the spectrum is an ecosystem service that potentially has global consequences. It's the blue carbon function of salt marshes, and that's that salt marshes are able to capture an unusually high amount of carbon dioxide from the air in their living plant tissues and then bury it in the sediments of the marsh. We have some cores that go back to salt marshes from 5,000 years ago, but for this study we're really focusing on the top layer. We've been measuring the biomass of the plants per meter squared and what's in them on top, so we can quantify how much carbon is captured in the plants themselves in the salt marsh. And then we've been taking sediment cores, 30 to 50 centimeters of sediment from the marsh, to measure how much carbon is actually buried. And the great thing about salt marshes is that it's buried forever, because as water levels rise each year, the salt marsh grows higher and new layers of carbon are buried in the salt marsh every year.
Thanks so much for showing us around, Kirsten.
Yeah, thank you for coming. We're very hopeful that through conservation and education and research we can take care of these special estuarine ecosystems.
We're out on the main channel of Elkhorn Slough today with Ron Evie. Ron is a citizen scientist who's worked at the slough for over a decade now, focused on work involving the sea otters who've recolonized the slough in the last 25 years. Ron, thanks so much for having us out.
Oh, I'm glad to have you here. We're just in the very beginning part of the slough, so we've only gone about 1.5 miles so far, but you can see all the wildlife that we got to see. And it's really quite impressive. I started this by kayaking for Team Ocean, and one of the things in particular that was different from the training that I'd had was we were seeing what the otters were doing. And we saw that the otters often were holding out on the beach, mainly at night. I had a friend, Robert Scholes, and I decided we'd start trying to see how much they were foraging there. At that time, we weren't citizen scientists at all. We were just naturalists observing something. But what was really fortunate is we had a scientist take us under her wing. And she told us what we needed to record, how to record it, how to do it really in a scientific way. And what we found is that the otters in the harbor, most of them, 85%, were foraging out in the bay, so they weren't really coming down to this area, but they were using it as a refuge. So the colder it got and the more windy it got, the more miserable we were, the more otters we saw. We captured 20 otters, put transmitters in them, and we can really determine scientifically, using the same methods that have done in the ocean, how much time they spend foraging, how much time they spend resting. And because we have those radio signals that we can track them, then we can do what we call activity budgets, where we follow them for 12 hours a day. The other thing we do is foraging budgets, and that's where we monitor exactly what they're eating. So we time, as soon as they come up with a prey item, how much time they spend handling it, whether they use a tool to open it, how much time they spend eating it, how much time on the surface grooming before they dive again, and then how long it takes them to come up with the next prey item. And by measuring the prey size, what the prey type is, we can see what the caloric demands are to do that effort of getting that prey. And by measuring those animals that we've capped, we know what the caloric gain is. So we can see how easy it is for them. And we found that. It's much easier for them to meet their caloric needs here in Elkhorn Slough than it is out in the ocean. You can just imagine out in the ocean, a mother with a pup, she's got to dive down, leave the pup on the surface, find the forage, come back up, find her pup, then eat her prey. In the meantime, she's got all the waves. And as you can see here, it's just an ideal habitat for the otters. The really cool thing is the otters are good for Elkhorn Slough. They eat the crabs that are in the eelgrass. By getting rid of the crabs, the Taylor sea hares can survive. What we have here is a Taylor sea hare. This is a small one. They can get up to be about the size of my little finger, but you can see it has been foraging up and down this piece of eelgrass. They go up and down the blades of eelgrass and keep eating all the microalgae off. When they get the eelgrass clear like this, then it can photosynthesize. These blades here, Taylor sea hares have not cleaned them, and you can see all this microalgae. We have so much excess nutrients in here that the microalgae just flourishes like crazy. The only thing that keeps them in check are these little critters. Eelgrass is perfect for Elkhorn Slough. It slows down the currents, which enables more sediment to come out. Our ebb tides are stronger than our flood tides, so we're losing sediment. The eelgrass beds help hold that sediment. and it's an ideal nursery. It's a habitat for all kinds of fishes that are out in the ocean. They grow right here in these eelgrass beds. Ironically, bringing the top predator back, which is the otter here, that trophic cascade is back in play. Otters eat the crabs, slugs survive, eelgrass thrives. The otter population is stalled, and there's really nowhere for them to go right now along the coast. They only have a two-dimensional way to go, and they've only gotten so far, and they're kind of barriers at the end. But by learning how well they use an estuarine environment, and there are other estuaries, Morro Bay, up to San Francisco Bay and all, where historically there were more otters just in San Francisco Bay than there are in the whole range now. So if we learn what we learn here can be applied to other estuaries, we may find the key to helping the otters break out of a threatened species status. Otters originally were all up and down the coast, but what happened is the fur trading began. The Russians came over and they began killing a lot of them, selling the furs. The Chinese began doing it, we began doing it, and with all these different organizations hunting them, they hunted them almost to extinction. In fact, it was thought that the southern sea otter, which is now recognized as a different species, was totally extinct. Fortunately, there was a small group that lived down off Big Sur, and when they did discover they were there, they kept it really quiet. By then, protections had been created to protect the otters. So from that small group of 50 to 100 otters, they've been expanding up and down the coast. Along the way, in about the 1990s, some of them that were used to an ocean environment, so they weren't used to a place like this. This was strange. But they began coming here, first some males checking it out, then they left, and then the females came in. Females had their pups here. Females taught their pups how to use an estuarine environment, and now it's grown to where we have well over 100 otters living right here.